All right, let's create a simple Java project to demonstrate JUnit test. I'm using IntelliJ, their most recent updated version, I assume. If you're not using 2023.2, I would highly recommend please update. Okay, we can name it hello test. Language is Java, but the build system is most important in the initial configuration. There are three versions: IntelliJ, which is the native IntelliJ version; Gradle, older Java build system, but the one almost 80%, 90% Java programmers use is the Maven system. Please use Maven because I found it to be the most painless, most convenient option. We don't need any sample code, so uncheck and then create. All right. The first thing we need to pay attention to, it's an error, all right, errors are gone. Yeah, the first thing we need to focus on is the POM file, POM file. As we are adding new libraries, Maven system internally creates dependencies as a new lines here, and it resolves dependencies between multiple versions, multiple libraries, all by itself. For now, take a mental note that my current file has only 15 lines, and we'll come back and check this file from time to time. Okay, let's see the folder directory. Main Java, I don't have any class files, so my main and Java is empty. It also creates a test folder for us, and we don't have any test cases or test classes, so this is also empty. All right, let's create our first class file here. My plan for this class is to contain multiple library functions, and then we'll test each of those functions one by one. So I'd like to name it as lib class, means library class, L uppercase. All right, this is my lib class, and the first function I would want is prime. So public boolean is prime. It will take an integer number. For now, it will return only true. Okay. Let me write down a little more about this function. This function will return true if the input number is a prime, false otherwise. Okay. My current implementation is dead wrong. I'm saying true all the time. I'm not considering number in any ways. It's just true. We'll fix this function later, but now let's test how we diagnose this. My isPrime function is wrong. Okay. We need to create a test case. And the simplest one in IntelliJ is right-click on the function, look for the generate method, generate. There are multiple options I can do. The one I need is test. Test, all right. This step is very important. It says if I'm using JUnit test 5, it is not found in my current folder, current project. So I need to fix it. Let's click on the fix. All right. A few more things here. I don't need before and after setup. My current testing is very fundamental. There's only one method here, is function, so check. All right, okay. All right. All right. First, my POM, or the dependency file. In the past, we had 15 lines, like here. Now, they created dependencies. Within this dependency tag, they used JUnit, and the version for JUnit is 5.8.1. So Maven knows which version to use, and this is one of the reasons people love Maven-based build system. Next, we did not have any classes under test Java, but now we do have one. The convention in Java is use test as the suffix of the class you want to test. I think I name lib class. All right, there's a typo. Let's fix that. Refactor, rename, remove 1a. Quite intelligent. All right. Oh, something happened again. Refactor, rename. All right. On my left, you'd like to see my original function, which is part of main Java lib class, and then my test function, which is test Java lib class test. All right. In my previous video, I mentioned we need some notion of ground truth, and then we test our function against that ground truth. All right. My ground truth could be any number for which we know whether it is prime or not. So let's pick a number like 3. Integer, my number, or just number is 3. We know the ground truth, which is boolean gt. This is 3 is a prime number. How do we know? From our math class. So this is true. This is the ground truth. And now we need to know what this function says about 3, which means we need to use this function is prime, which means we also need to create an instance of lib class. So let's do that. Create an instance of lib class lower lib class equal new lib class. All right. And this time I need the output boolean result. My lowercase lib class is prime. I'll be passing any number, in this case 3. Okay. All right. Now that we know what this function will return, which is a result, and we know result should be true. That's the ground truth. With these 2 pieces of information, I can call the assert function. Assert equals, first parameter is always the ground truth, gt, and the second is the output that function returns. Use the assert method. Okay, save. Now I can run. Yeah, there you go. My test is successful. It says it's passed. It's a green check mark. I'd like to take a moment and rethink whether our test case is great or not. Clearly this function is dead wrong, but my test says it's green, it's passed. So what did we do? Well, this test outcome happened by chance. If we pick a different number, let's change my number to try with another number. Try with 4. 4 is not a prime. How do we know? From math class. I'll be skipping 2-3 steps. We don't need to declare local variable. We can put them into our assert method. Use that. Here we know instead of result we need to call this function. No number, we try with new parameter, which is 4, and we know 4 is not a prime, so the output is false for sure. Okay. All right. Let's test it. Yay, this time it says test failed. 1 test failed. First assertion, it was passed by chance, but the second one failed. So what's the lesson here? Lesson is I need to try multiple numbers. But how many numbers? 3, 4, any numbers? Many people try 7, 11 numbers. When we try multiple numbers, copying and pasting code is kind of boring. So they use assert array equals. This is the function most people prefer. Okay, now I'm not gonna write assert array equals because the concept is very similar. Instead, this is your to-do. We comment out all the single instance based testing, command / all right. And this is what you need to do. You need to create an array of random numbers. You can call this array as just numbers. In this array we have a collection of, again, random numbers: 2, 3, 5, 11, 9, 20, 28. Then we need ground truth for each number. We know 2 is true, 2 is a prime number, 3 is a prime number, so true. 11, prime number, true. We know 28 is not a prime number, so false. 20, not a prime number, false. 19, prime number, true. Okay. Once you have this ground truth boolean, name it as GTS, ground truths. Then you need another array which will hold the output for each of this number. To create output variable, output array, you can add one output at a time. So first run it with 2, get the output from the function, isPrime function, append it to our output array or output list, continue doing it until you add all of them, and finally use assert array equals GTS, the ground truth, and the outputs that we got from our isPrime function, and try and run. When it is done, run isPrime. Right now it says it passed because there is no test going on here. In your scenario, hopefully it will fail. Alright, I look forward to seeing your code. Bye.